let us bring the IUPAC naming of alkenes. All right, so alkenes, if you remember, we said they are what we would call unsaturated hydrocarbons, and then they have a functional group, which is the double carbon bond, carbon to carbon bond. Where's our table? Right, so we are on alkenes. They have these double carbon to carbon bonds, right? And then their suffix is ene or in, right? So that's one thing we need to note. And then when it comes to their general formula, we use CnH2n, where n represents the number of carbon atoms. So if we know how many carbon atoms we would have in a specific alkene, we can sort of determine, before we even sketch the structural or condensed structural formula, as to how many hydrogen atoms it will have using that general formula. All right, so those are the characteristics of alkenes. Right, so now we will just be naming them, and then just note that most of the things are similar to how we were doing them in the alkanes, especially the branched chain alkanes. Okay, so just like any other organic compound, the names will have a prefix, a stem, and then a suffix. All right, so just to put the characteristics here for you of alkene, right, we have those characteristics. So these are unsaturated hydrocarbons, and then everything else we've already spoken about. All right, so let's go to the rules of naming these homologous series. So like I said, the rules are pretty much the same. So yeah, these are typically the rules, and then you number the carbon atoms in the main chain from the side nearest to the double bond. If you remember our alkanes, when we number the carbon chain, we would make sure that we start from the side nearest to the alkyl group. So in this case, in the case of alkenes, the double bond takes preference. So we prefer starting from the side that is closer to where the double bond is located, right? Even if there was an alkyl group, we would overlook that. So our priority list, number one on that priority list is the double bond, then followed by the alkyl group, right? So the double bond will always take preference. And then after, we just number the substituents, also called our alkyl groups, and then we write down the full IUPAC name once we're done. So let's just take examples and see how we do this. All right, and then just before we do that, with alkenes as well, we have what you call simple alkenes, and then they behave similar to the simple straight chain alkanes. So if you remember, we would count the number of carbon atoms in that simple alkane, and then we would then give it the name. So if it has 1, it would be methane, which usually would look like C, right, something like this, or simply CH3 if you're doing it in condensed structural formula, all the way up to until decane, right? It's the same with alkenes. So the only thing is, now we are replacing these suffixes with the alkene suffixes. So instead of it being ANE, it would be ENE. So it would be methane, ethene, propene, butene, all the way to decene, or whatever that would be called, right? So we are merely replacing the ANE, because that suffix belongs to alkanes. So in the case of alkenes, that's the difference. So let's just simply say now, in the case of, we can take our table. All right, so here's what I mean. Now we've put it into this table. So remember, we count how many carbon atoms that particular organic compound has. So starting with straight chain alkenes, this is if the alkene has no branches or no substituents, or rather alkyl groups that cause us to get branches and so on, right? Just a simple straight chain alkene. If it had 1 carbon atoms, it would be called methene. If it had 2, ethene. If it had 3, propene. 4, butene, and so on and so forth. Hexene, heptene, octene, nonene, decene, right? So this is how we would name them, only if it's just a straight chain alkene. So usually what happens after we reach propene, we rarely find straight chain alkenes. So you start finding alkenes that have branches and alkyl groups after that. So that's what typically happens. So what we end up having is we use these straight chain alkene names to name our parent chains, right? Because if you remember, even when we were naming alkanes, we would count the longest continuous chain. We count how many carbon atoms does it have. If let's say we find that it has 5 carbon atoms, the name of that chain would be pentane, right? And then we start combining all the other stuff to then form the IUPAC name of the full compound now, right? So similarly here, once we move away from straight chain alkenes, we will have to count the longest carbon chain in that alkene, and we would give it a name based on how many carbon atoms are in that long continuous chain. So if, for instance, that long continuous chain has 5 carbon atoms, we would call it pentene. And then we would go and then try to find if there are any alkyl groups. And then once we find those, we combine to form the full name now. So we will do examples though, don't worry. So this is for straight chain alkenes. Right? But we said note that you will not always find straight chain alkenes after propene. So we would instead use these names for the long continuous chain in a branched alkene. And also, after propene, we have to start considering the position of the double bond across or along the continuous carbon chain. So we can't just come and say it's called butene, for instance, right? It becomes something else. So for that reason, we need to note that here. For that reason, you'll find that you will rarely, if ever, find an alkene with these names from butene all the way to decene, right? Because you have to specify where is the double bond located, and usually we use a number. So after propene, there's no simple name. You have to account for the location of the double bond along the carbon chain or along the continuous carbon chain. All right. So we can say perhaps this would be for the main chain. All right. Not necessarily the whole alkene, but the main chain. Okay, it's fine. So let's see how it looks like when we follow the rules. Here's an example. All right, so we have this example right here. Example 1, we have this particular alkene. As you can see, there's a double bond somewhere in between those carbon atoms. And now we must find the name of this one. So remember, our rule says first things first, you identify the longest continuous carbon chain. For this one, it's quite clear. It's just this whole. This is our longest continuous carbon chain. From the diagram, we can sort of see that. Okay. That's our main chain or parent chain. Depends which one you prefer using. All right. So how many carbon atoms in the main chain? All right, so let us start numbering this main chain. So if I want to number from right to left, I would say 1, 2, 3. So the location of the double bond is carbon number 3. Okay, so how do I know that? Because when I was counting from right to left, I first saw the bond on carbon number 3. Right, I don't have to wait to get this to this one and then say it's on carbon number 4. That's not how it works. You check what's the first carbon that you reach where the double bond is located, and then that's the number you use. Okay, so it's 1, 2, 3, 4, and then 5. All right, so the main chain is 5 carbon atoms, so we can put that there. It is 5 carbon atoms. Now if I were to number the same carbon atoms, but now from left to right, I would say 1, 2, 3, 4, 5. Okay. So if you check, when I number from left to right, my double bond is on the second carbon atom. On the other hand, when I number from right to left, my double bond is on the third carbon atom. So I have to choose the side that allows me to have the least number possible. So I have to choose the side that is nearest to the double bond. So where the double bond is at its position is a lower number, not a higher number. So in this case, I choose left to right. Why? Because the double bond is on carbon number 2. Whereas if I were numbering from right to left, it was going to be on number 3. All right, so we choose that one. So it's on number 2. And then since our main chain has 5 carbon atoms, what is the name of the main chain? Remember what we said? We use this list right here. For 5, this is what we have, pentene. Okay, so we can put it there. So in this name, there's the stem and then there's the suffix of the homologous series. Remember, a homologous series is alkene in this case. So pentene, which has pent for 5 and plus ene for the fact that it's an alkene. Okay, pent for a stem name saying there's 5 carbon atoms, and then ene for the suffix. So our suffix is our ene. Right, and then now we can write the full name. So luckily in this case there's no alkyl group, so our full name would be, let's check. First, we have to specify the position of the double bond. We said it's on carbon number 2. That's 2 dash. And then now we put the name of the main chain because there's no alkyl group. So we put pentene. If there was an alkyl group, we would first put the name of the alkyl group and then lastly put the name of the main chain. Right, so this is how you would name this one. So if you go to other textbooks, you'll find them doing something like, oh, can say O, they'll say pent, right, to in, right. So that 2 between the stem and the suffix tells us the location of the double bond. I usually prefer the first option because it's easier to remember for most people. but if you are into this naming as well, you can use that. So that's one thing about alkenes. You can either use that or this type of naming. Okay, but anyways, you will still be correct. All right, so that's how we would do it for this compound. Now let's take our template here. In fact, we'll bring it here again. All right, we'll come here again. So let's number. Let's count, or let's find the longest continuous carbon chain. 1, 2, 3, 4, 5, 6, 7, 8. Okay, that's chain number 1. 1, 2, 3, 4, 5, 6, 7, 8. That's chain number 2. And you know, by default, I will choose the straight one because it's convenient for me. And also, I've noticed that it doesn't matter which chain I use, they both have 8 carbon atoms in them. Okay, so let me use this one. You can use the branched one as well, doesn't matter. So you can either use this chain or you can use the straight one. I always opt for using the straight one. It's just a preference thing. All right, so in fact, all right, so we have that. That's our main chain. Okay, and then now we can see something outside the main chain. Remember what we always call them, an alkyl group or a substituent. So this is an alkyl group. And what is the name of this alkyl group? Since it has 1 carbon atom, it's called methyl. Okay, it's an alkyl group called a methyl group. Right, so now let's start numbering our carbon chain. If I number from right to left, here's what I get. I get 1, 1, 2, 3, 4, 5, 6, 7, and then 8. Okay. On the other hand, if I number from left to right, I get 1, 2, 3, 4, 5, 6, 7, 8. So which side do you think is better to number from? Is it from left to right, or is it from right to left? Which one? All right, so if I check here, it's best for us to number from left going to right. Why? Because when I do that, my double bond, because remember, it has to take preference. We must number from the side that is nearest to the double bond, always for alkenes. Okay, the double bond takes preference. So I see that it would be number 2 on this location. It will be located on carbon number 2. Whereas if I were to do it from right to left, it would be number 7. So I don't need that. I'll use from left to right. That's my numbering. Okay, so I think let's also specify here. That we number the carbon atom from which side to which side because it's closer to the double bond. All right, so I just added that here for our first example. We number the main chain from left to right because this side is nearest to the double bond compared to numbering from right to left. Okay, so we'll do the same thing for our example 2. We will add that description. All right, so similarly here, we found that numbering from left to right is much better. So we'll just add another description here for, because remember our steps say we need to include the position of the alkyl group. And maybe the name. All right, so let's fill our form. So number of carbon atoms in the main chain, we found that there are 8. Right, we'll put our 8 here. And then position of the double bond, we found that it's on position 2. And then position of the alkyl group, it's also on position 2 of the carbon chain, or it's found in carbon atom number 2 along the long continuous carbon chain. And then the name of this alkyl group, we said is the methyl group. And then the name of the main chain, because now the main chain has 8 carbon atoms, what is its name then? We come here, we found that 8 corresponds to octene. All right, so this would be octene. All right, and then our suffix, of course, we are still on alkane, so our suffix is the same. It's ENE. Well, there's no need for me to specify it here because it's already included in the name of the parent chain or the main chain, but it's fine. Let's put it here. Then now let's try to write the full IUPAC name. Remember what we do, we start by listing the methyl group and then followed by the name of the main chain or the parent chain. And then we have to specify also the position of the double bond across or along the main chain. All right, so we found that our methyl group is on position 2, so we'll say 2 methyl, right? And then we found that on the same carbon chain, the double bond is located on the second carbon atom, so it would be 2, and the name of this carbon chain is octene because it has 8 carbon atoms in it. So that's our name. And then O, remember, I'll always give you 2 ways for these ones because there's 2 ways of doing it. You will still keep the same thing, 2 methyl, similar to our previous example, but now, and then you say oct 2 ENE, right? So saying on the second carbon chain, second carbon atom along the main chain, you'll find a methyl group, and then you will also then find the double bond on that very same second carbon atom along the continuous chain. So that's what this name is telling us. So from this name, you can also be able to sketch. I'm not sure why I keep saying sketch, but you can be able to draw the structural formula. So if you're given this name, you should still be able to construct a structural formula or a condensed structural formula, right? But we'll get to an example like that later on. Okay, now let's go to our next example. Okay, now we are faced with this structural formula for another alkene, and then we must, as always, first find the longest possible continuous carbon chain. So let's start from here. 1, 2, 3, 4, 5, 6, 7. Okay, the straight one is giving us 7. Okay, that's the highest number we have so far. And then we go here again. 1, 2, 3, 4, 5, 6, 7, 8. Oh, the L-shaped one gives us 8. Okay, so the highest number now becomes 8 and not 7. 1, 2, 3, 4, 5. All right, so now if you check, I can't include this one. I can't use this chain. Why? Because part of the rules say, let's go back to our rules actually. Find the longest chain which contains the double bond. Right? If the chain doesn't contain a double bond, it doesn't qualify as a chain in the case of alkenes and alkynes. Right? So what that means is the only valid chains that we have here is this one or this one, the L-shaped one. And since we know that the L-shaped one has the longest chain, we will take that one, the L-shaped one. As long as it includes our double bond within the length of the chain, we're fine, we can use it. All right, let's do that. So it goes from here all the way there, comes back here. All right, that's our parent chain or main chain. Okay, now if you check from our main chain, we see two structures that are outside it, our alkyl groups. This is alkyl group number 1. And then this is alkyl group number 2. Okay, so since it has one carbon atom, it's a methyl. Same as this one, fortunately. It also has one carbon atom. What have we done? Okay, it's fine. Let me just write it. This is also another alkyl group. Let's call it methyl because it has one carbon atom. All right, so we have two alkyl groups and one double bond. So our main chain has 9, was it 9 or 8? 1, 2, 3, 4, 5, 6, 7, 8. It has 8 carbon atoms. All right, so let's start numbering it and see which side is better. From just looking at it, I can see that it's better to number from the right going to the left, which is from this side. 1, 2, 3, 4. So if I number from this side, I can see that the double bond is located on the 3rd carbon atom along this continuous chain or along this main chain. And then I continue 5, 6, 7, 8. I can still check the other side, it's fine. From left to right. 1, 2, 3, 4, 5. So you see this one won't really work. Between 3 and 5, I'll choose the 3 because it's a lower number. Then this is 6, 7, 8. Okay, so I'm choosing to number from right to left this time around. So I'll remove this and say from right to left instead of numbering from left to right. So that's what we're choosing now. It works. This one works better. All right, so now what are the number of carbon atoms in the main chain? We said we found them to be 8. 1, 2, 3, 4, 5, 6, 7, 8. And the position of the double bond is position number 3. Position of the alkyl group, it's on number 3 and on number 4. Okay, because if you check here, it's here and also it's there. So that's carbon number 3 and carbon number 4, and it's the same alkyl group if you check. All right, now the name of the alkyl group, they are both methyl groups. Both of them. And then name of the main chain, since it has 8 carbon atoms, remember it would be octene from our nice table that we did earlier on. All right, so from here now we can then start putting the name together. So we notice that we have 2 alkyl groups, so we can put them here. We start with the one that appears first. It's on position 3, so there's 3. Now since they are of the same kind, I have to separate their numbers by a comma, 4, right? Then dash. Now I have to write the methyl or the alkyl group name. Since there are 2, I have to use the Greek prefix di. Di means 2. Dimethyl. Remember, whenever you have identical alkyl groups, you start using Greek prefixes, right? Otherwise, you won't represent them properly. So now that we are done with the alkyl groups, we can then now mention the position of the double bond and then finish off the name. Position of the double bond is number 3 and then octene, the parent chain name. Or remember, I will do it in two ways. We still get our 3.4 dimethyl, but now we say oct 3 ENE. That's another way. All right, so that's what we would typically do for these alkenes. All right, so now we will check out what we call die-ins. But before we go there, just wanted to highlight this, that there's a Greek prefix here. Because we have 2 alkyl groups. They are not just 2 alkyl groups, but they are 2 identical alkyl groups. The keyword here is identical. If they are not identical, you can't use the Greek prefix di, tri, or tetra. Okay, you can't use those. So it's only for if they are identical. Okay, all right, so let us push forward to our next part of the examples. All right, let's check this example that has a condensed structural formula. So we already have our template here ready to go, and then we'll fix this part when we start numbering. Okay, so now let's check what is the longest chain here. Let's start. Remember, it must always contain the double bond in it. If it doesn't, then it's not the longest chain, or it doesn't qualify as the continuous chain. 1, 2, 3, 4, 5. So the straight one has 5. Let's try another one. 1, 2, 3, 4. Okay, this one is lower. 1, 2, 3, 4, 5. So I can either go with the straight one or the L-shaped one, but you know me, I'll pick the straight one. I'll pick this one. Why? Because it's convenient. Right? So this is our main chain. Okay, now we have our alkyl groups. This is alkyl group number 1. And this is alkyl group number 2, or substituent number 2, or a branch number 2. So this one has 2 carbon atoms, this alkyl group. It's an alkyl group, it has 2 carbon atoms, right? And because of that, it's therefore ethyl. If you remember our table of alkyl groups and their names, and this will be methyl. This is also an alkyl group. Okay, so we have those, and then now we can start numbering this chain. So we number from the side. That will give us the least position number for the double bond. And if you can check here, it's already clear that if I number from left to right, the double bond will be closer than if I number from right to left. But like I always say, let's prove. So now we have 1. If we do it from right to left, yeah, we have 1, 2, 3, 4, 5. It has 5 carbon atoms, right? And then if we number from left to right, on the other hand, we have 1, 2, 3, 4, 5. So if you check, if I number from left to right, my double bond is on carbon number 1. If I number from right to left, my double bond is on carbon number 4. So you see, I have to use left to right. So this one, I'm just sticking to the same color scheme so that when you go to our numbers there, you can see it. Instead, all right, so that's what we have. In fact, I should change this too. All right, now it matches. Okay, so we have that. Now, how many carbon atoms are in our main chain? We found that there are 5. And what's the position of the double bond? We said it's 1. And then position of the alkyl group, 1. One alkyl group is on position number 2. So which is the ethyl group? There's 2 for ethyl. And then there's also, which is the other one, number 4 for methyl. All right, name of the alkyl group, there's 2. Okay, let's just write 2 and 4 here, it's fine. The names, we have ethyl, and methyl respectively. I'll follow the same order as above. So the number or the name of the main chain becomes pentene because it's 5. Remember that. Let's go check our table. Where's our table? Should be here. Yes, since it's 5 atoms, it's pentene. 5 atoms in the continuous carbon chain, the main chain. All right, so we have that. Now we have all the information we need to compile the full IUPAC name. Remember, we always start with the alkyl groups first. So we know that there's an alkyl group in position number 2, and that alkyl group is ethyl. There's another one in position number 4. It's called methyl. Now we're done with the alkyl groups. So now we must specify the position of the double bond and then write the name of the main chain once. Right, so we found that it's on number 1, the carbon atom number 1. If you can remember here, that's where it is. If you were to draw this, you would find that H is like this, and then there's that, and so on and so forth. So that's why we're saying it's on carbon atom number 1. Okay. All right. In fact, let me not erase that. Number 1. So 1, and then we can write our full main chain name, which is pentene. And then remember, there's another alternative, or you can do the same thing. You'll have 2-ethyl 4-methyl, and then pent 1-ene. I hope you are getting the hang of it by now when it comes to naming using the other method. All right, so I prefer the first one, but yeah, this is how we would name these organic compounds. All right, so like I mentioned earlier, there's now a concept of dienes, which is another, still alkenes, but now what happens is they have double bonds that are repeating within the carbon chain. So this diene means there are 2 of those double bonds instead of having 1 now. So how do we name dienes then? So the big question becomes, what if what if we have 2 double bonds in the carbon chain? It's called a diene. We get a diene. So rules for naming dienes are as follows. Same thing as we have been doing. All right, so these are the rules for naming these dienes. So basically a diene, if you see that in your carbon or parent chain, or the main chain rather, that you have two double bonds that are present there, that's automatically a diene. And when you are numbering that chain, or when you are choosing the longest chain, you must always make sure that those double bonds are within that chain. So similar to how we were doing it for just a single double bond, we would make sure that it's part of our long continuous carbon chain, which would eventually become our main chain. Right, so same story here. And then again, same thing, we start numbering from the side, which would allocate the lowest numbers to the carbon double bonds. All right, and then again, same thing, we separate numbers by commas and add in front of the name. Substituents are named as same as we've been doing, which is what we've been doing for alkanes, and again the simple alkenes that we've done thus far. All right, so let's just check examples. This one is best illustrated by examples. All right, so this is our example. It's a condensed structural formula. So this one was a simple straight one. So if you check, this would be our main chain, right? It's just a straight chain in this case, right? So in our main chain, what happens is now we can start counting the number of carbon atoms. We have 1. In fact, let me change that. We have 1, 2, 3, 4, 5. No. apologies. Let's start counting from right to left and then from left to right and see what happens. From right to left, we have 1, 2, 3, 4, 5, 6, 7, 8. Okay. So when we count from right to left, the first the first double bond is on the first carbon atom, and then the second one is on the fifth carbon atom. So what happens if we do left to right now? 1, 2, 3. So from left to right, the first double bond is spotted on the third carbon atom. Okay, 4, 5, 6, 7, and then the second one is on the seventh carbon atom, 8. So if you check, I have 2, 6, and then I have 3 and 7. So it's advisable for me to then number from right to left, because the first carbon atom, when I number from right to left, the double bond is first seen on the first carbon atom, whereas when I number from left to right, the double bond is first seen on my third carbon atom. Okay, we continue. When I number from right to left, the second double bond is seen on my fifth carbon atom, whereas when I number from left to right, the green, the second double bond is seen on the seventh. So you see, your numbering from right to left is way better because I get smaller numbers for these bonds. So I will choose to number. In fact, let me bring back this one. So it's better if I number from right to left. So let's be a bit lazy here. Right. It's better if I number from right to left than from left to right. Okay, that's what we have now. So we can bring back our template, actually, all of it. Can bring back all of it. Okay. So how many carbon atoms do I have in the main chain? I have 8. Right? And then what's the position of the double bond? So in this case, it's double bonds, not just one, but 2. So I see that the first one is on carbon 1, and the other double bond is on carbon number 5. Position of the alkyl groups, none. There's no alkyl groups. Name, there's none. Let's say Na. In fact, we can remove this. Alright. And then we can only have that. So name of the main chain, since it has 8 carbon atoms, and remember now the suffix changes. It changes to diene, like this, instead of just ene. Now it's a diene. So the name of the main chain will also have diene in it. So we're still using the same concept we were using when it was just a simple alkene. So since there are 8, it means it's an oct, but it will be octadiene. Right, we just changed the suffix. Right, so that's the difference. It's an octadiene. Okay, so let's combine the name now. There is no alkyl group for now, unfortunately, so we will have to just mention where the bonds are, which is 1. Remember, we separate numbers using commas, and then 5 dash octa diene. Okay, so that's one way you would have done it. Or remember, you can say octa. So if you notice now, when we talk about diene, we add this extra a, but if it was just a simple alkene, it was going to be octene, right? Now since it's a diene, we have to say octa diene. Okay, that's one thing I want you to note. This is for simple alkane with one bond. Right, this one is for dienes. There's a difference here in that, so we add that extra a there. All right, so this would be octa, then you add your 1.5, which tells us that my double bonds are found in the first and the fifth carbon atom along my long continuous carbon chain. Then you put your suffix at the end, your diene. Yes, so that's how it works. Okay, so that's how it works for dienes. We number them the same way. It's just that now what's different is there are two double bonds within the main chain, or in the main chain. So now we have another example again. So in this one, let's check. If we want to count, or if we want to identify the continuous chain, we go 1, 2, 3, 4. Now the trick here is I can't go 5, 6, right? Because it leaves out this double bond now. So there's only one double bond in my continuous chain. So that continuous chain doesn't qualify. So I can't use that. So I have to continue and go all the way there. So it means there's only one chain that I can identify here, or that's valid. So it has to be this one. That's my parent chain. Or main. These words are used interchangeably. All right, so we have that, and then now it means we have an alkyl group now. This is our alkyl group. And our alkyl group has two carbon atoms. What that means is it has to be an ethyl group. Because it has two carbon atoms. Okay. All right, so now we can start counting. Which side is it better to count from? Again, we try. We go from right to left. We say 1, 2, 3, 4, 5, and then 6. So when we count from right to left, we notice that the first double bond is on the first carbon atom, and then the second double bond is on the fifth carbon atom. Now let's check if we count from left to right. We have 1, 2, 3, 4, 5, 6. So it makes no difference. It makes no difference. In this case, you can count from any direction. Let's do this. Because when I count from left to right, my first double bond is on the first carbon atom, and then my other double bond is on the fifth carbon atom. Same thing when I count from right to left, my first double bond is on my first carbon atom, and then my last double bond is on the fifth carbon atom. So it doesn't matter here really. So now what we can then do is we can then now, only then can we start considering our alkyl group, right? So if we check, our alkyl group is closer if we number from left to right, from right to left, because it's on number 1, 2, 3. It's on number 3. But if we number from right to left, it's on number 4. Okay, let me say that again. If I number from left to right, the alkyl group is on number 4. And then if I number from right to left, the alkyl group is on number 3. Do you see it? So we'll use the one from right to left so that the alkyl group also gets a lower number. Otherwise, as soon as we are done prioritizing our double bonds, we can then check the alkyl groups really. But our main priority has been served, so the alkyl group is the second priority now. So let's name it here. So let me just see atoms in the main chain. But before we get there, I want us to note that numbering from whichever side doesn't make much of a difference, but we prefer numbering from right to left because the alkyl group is closest like that. It's at the nearest. Okay. Right, so just like I said, numbering from either side, we see that the double bonds are found in similar locations, so it doesn't make a difference. So what we decided to do is we choose to number from right to left, as this is makes the alkyl group to be at the nearest location. All right, compared to numbering from left to right. All right, but it's always good to remember that double bonds will always take priority. We'll look at the alkyl group later. In fact, ideally, it should not be incorrect even if you continue numbering from left to right in this situation, because you have prioritized your double bonds, okay? All right, so we have six carbon atoms in the main chain, so we can put that there. 6. The position of the double bonds, they are 1 and 5. Position, location 1 and 5. In fact, I think we should opt for location and not position. All right, so location of the alkyl group, we find that it's on location number 3. Name of the alkyl group, it's the ethyl group, like we've already discussed. And then name of the main chain, it's a diene, remember. The suffix here will be a diene. So name of the main chain is, it's 6, so it has to be hexadiene. Remember that extra A that we add there, diene. All right, so now let's combine it into one full name. And then we start with the alkyl group always. The alkyl group is located in position 3. Ethyl, there's only one of them, so ethyl. Now we can talk about our double bonds. They are located in 1 and 5, and it's a hexadiene parent chain. Okay, or remember, I will always do 2 of them for the guys that prefer the second one. Ethyl hexa 1.5 diene. Okay. All right, so this is pretty much how you would answer questions like this one, or how you would name a diene like this one. All right, so now for our last set of examples, I want us to try and draw the diene and the other alkenes based on when we are given a name. Like, let's say they give us a name, and now we have to draw what it would look like. Okay, All right, so let's start with these simple alkenes. So we are given 2-methyl. This would be our number 1. This would be our number 2. We are given 2-methyl pent 1-ene. Okay. Remember what we said. We said this one tells us the position of the double bond in the main chain. So no, let's call it location. Right, location of the double bond on the main chain. And this one tells us location alkyl group location. So we can start sketching. Okay, so and then from here pent tells us the length of the carbon of the parent chain. Don't want to use too many colors, but yeah. Or parent chain. And then methyl obviously tells us the name, right? Name of alkyl group. Alright, so now that we have all that information, let's start. So we know that the main chain has to have 5 carbon atoms in this case, right? So let's sketch 5 carbon atoms. Let's draw 5 carbon atoms. 1, 2, and 5. All right, now we have a pentene chain. All right, so now we are told that the location of the double bond is on the first carbon atom. You don't start assuming that your chain is zigzagged or not. You always assume it's just a straight chain. You will add other stuff as you build it. Okay, don't start doing stuff like this and you are guessing what the chain might look like. No, you don't need to do that. Just assume it's a straight chain and take it from there. All right, so now we are told the location of the double bond is on the first carbon atom because that's number 1, so we put it here, number 1. Okay, and then we are told that the methyl group is on the second carbon atom, so we can put it there. That's my methyl group. And then from here, what else do we need? We're pretty much done, right? We just need to make sure that there's a correct number of bonds on each carbon and hydrogen atom. So here there's 4. There are 2 here. I need 2 more to make it 4. And then these are finished, 1, 2, 3, and 4 with this one, so it's fine. Here I need 2 hydrogens. I need 2 hydrogens there. I need 2 hydrogens there as well. Then we're done. That's how you would sketch the structural formula. All right, so this is for the first question. For the second one, I won't take out the stuff like I did in the first one. I will just sketch it because it's the same thing. So it's 2-dimethyl pent 1-ene, 2.4, sorry. So now this was number 1. Now we're on number 2. Right, the only thing I would like to point out is that there are 2 identical methyl groups given by that Greek prefix di. All right, so there are 2 of them. Now let's start sketching our chain again. In fact, I think let's take this one and copy it from here instead of doing it from scratch. Yeah, we can take it as it is and then we'll modify it because it's the same length, still pentene as well, and it's the double bond is still located on the first carbon atom, so we just need to change a few things or add. All right, so we are told that the double bond, this guy here, it is, it's located on the first carbon atom. Okay, and then we are also told that the 2 identical methyl groups, one is located on carbon number 2, which is this one. That's 1, that's 2. The other one is located on carbon number 4, which is that one. So here I have to come, in fact I don't have to put it here, I can put it up there. So you see, these things, they come and substitute the hydrogens. Where hydrogen was, you find suddenly an alkyl group. Or is it too far? Let's put it here. So now I can come put it there, then do have that, an H there, an H there. Oops, seems like, okay, let me drive it down, and another H there. All right, that completes our problem. This is how you would answer a question that asks you to draw these things. All right, so yes, that's how you would do it. Okay, now let's look at an example where it's actually even this one would still work. This is another example. Let's call this example 8. All right, this is example 8. Again, what we do, we have all this information. So let me just, I won't label it this time. I'll be a bit faster. This tells us the position or the location of the double bond, that number, right? And then this number tells us the location of my ethyl group. These 2 numbers tell us the location of my methyl group. So there are 2 of these methyl groups, hence 2.2. They could have been in another position like 3.3, right? Or maybe 3 and 5, right? They don't always have to be in the same spot. So since they repeated the same number twice, it means that they are found in the same location. Okay, then hex tells us the length of the carbon chain. Okay, let's get to it. So we have to draw, hex is 6, right? So let's draw 6 carbon. Okay, now we have 6 carbon atoms. Let's start by locating the double bond, because we know it always takes precedence, it always takes preference when we are numbering the carbon chain. So it's on number 3. Okay, I will start numbering from left to right. So 1, 2, 3, it will be here. My double bond will be there. Now what else do we need? On the second carbon atom, I have 2 methyl groups. Let's put them there. I'll put one up here. I don't know why I made that stick that long. I want it to be, yeah. Then I put another one there. These are my methyl groups. They are located in the second carbon atom, both of them. So that's why it's 2.2 there. So just because they are in the same, it doesn't mean you write the number once. You have to write it twice because you are reporting each and every group that is in there. Okay. Now, where's the ethyl? The ethyl is on number 3. So it's here. Remember, ethyl has 2 carbon atoms. Okay, that's your ethyl. So you must be careful where there's a double bond. Don't add additional bonds here. So here I just need to add 1 hydrogen. If I add more, then my structure becomes incorrect because where's the extra covalent bond coming from? Okay, then here there are single bonds only, so I can still add 2 more. Hydrogen, hydrogen, and hydrogen there. And then here, finish it off as well. Hydrogen, hydrogen, and hydrogen. So this is what the structure would look like. All right. Okay. So yes, we have this being here. We have 2.2, which is this guy and that guy. Then we have 3 ethyl, 3 ethyl, which is that guy. All right. So we have all of these items now. So we are done with this one. Now let us check just one last example when we have a die-in now. So in this die-in, again, we get the same thing. All right, so we have something like this. Don't mind this was supposed to be a comma. It's a typo there. So we have this die-in, and then one thing I can just note is that this one will tell us, remember, location of the double bonds, cations, because there's 2 of them now, within or along the parent chain. All right, I won't name the other stuff because it's the same thing, or I won't label them because it's the same thing as we've been doing previously. This one, it's simply the length of the main chain. Die-in is telling us that this is an alkene that has 2 double bonds in it. And then methyl is the alkyl group, and 3 tells us the position of that alkyl group, methyl. Okay, so let us draw it. So remember what I said. Start by drawing the parent chain, and you assume that it's a straight chain. You don't draw zigzags and whatnot. You don't need that. Okay, so I'll draw 5 because penta is 5. So it's 1, 2, 3, 4, and then 5. All right, and then there are 2 double bonds. The first one is on carbon atom number 1. The other one is on carbon atom number 4. Okay, as you can see, 1, 2, 3. Oh, I made a mistake. This is 3 and then 4, so it has to be here. Yeah. All right, and then even if I'm counting from right to left, or whether or not I'm counting from left to right, I'll get the same thing. Now let's put our alkyl group. It's on number 3. 1, 2, 3. It's here. So let me come and put it there. C H. This is my alkyl group, my methyl. Then now I can finish off my diagram now. That's it. Oops, this is the mistake I was talking about. See, if you count these bonds, it's 1, 2, 3, 4, 5, so that's not possible. So I must remove one, which is this one. Okay, you can either put it up there or you can put it down here. No one will penalize you for that. So I just prefer it up here, and then here I put them like this, and then yes, that is our structure. Well, that's how this thing would look like. All right, so pretty much with all these principles that I've shown you on how to handle alkenes, including branched alkenes and dienes, you should be good to go and answer other IUPAC naming questions. All right, because so far we're just dealing with naming these organic compounds. So yeah, this concludes this part about alkenes. All right.